I knew it.
All right, ladies and gentlemen, boys and girls, why don't you speak up? Ladies and gentlemen, boys of all ages. So we're going to use the box method, 35 times 21. What place value is the 3 in?
30.
3, which is worth 30. It's 3 tens. What place value is the 5 in?
5 ones.
5 ones. What place value is the 2 in?
20 tens.
Okay, so 2 tens or 20. And then 1.
1 10.
All right.
I mean 1 1. Yeah.
So take 2 on this as we try and figure it out. We're working this together. And now it's just 1 digit by 1 digit. Since I messed up the first time, we're going to get it right this time, hopefully. Mina, what's 30 times 20?
30 times 20 is 60.
No. What do I do with these 2 zeros?
Oh, put it behind it.
Put them at the end. 600. Mina, what's 5 times 20?
5 times 20.
5 people give you $20 bills. What's 5 times 2?
5 times 60.
10. So 5 times 20 would be 100. All right. Mina, what's 30 times 1?
30 times 1 is
30. Mina, what's 5 times 1?
5 times 1 is 5.
5. All right.
That's just
Now check me because I messed up the last time. So does this look all right?
Yeah, that's correct. You put a 1 instead of
Yeah, I put a 1 and not a 5. All right, so then we just add our products all together. 600 plus 30 plus 100 plus 5. Dax, 0 plus 0 plus 0 plus 5.
35.
5. Dax, 3 plus nothing else. Dax, 6 plus 1. 7. Now, I like to check that with the standard algorithm. So we're going to look at that. 35 times 21, and we're not talking about the standard algorithm yet, so just chill, folks. You don't have to yell at me all the time. And we get 5, 3, 0, 0, carry 7. So we got 735. So we did it right. On your paper, you are going to solve that second problem on your own, and then we're going to go over it. Again, all we're doing today is talking about different ways to multiply. So this problem you're going to solve is 15 times 18. If you're watching at home, stop the video and solve 15 times 18 using the box method, please. All right, and we're back. Thank you, Grace, for volunteering to help us. Grace, what is 10 times 10?
100.
100. Grace, what is 10 times 8? 80. Grace, what is 5 times 10?
50.
And Grace, what is 5 times 8?
40.
40. And now we add these 4 products together.
270.
So 100 plus
270.
80 plus 50 plus 40. Are we doing this right?
Yeah.
17. Is it 270?
Wait a second.
Yeah.
Okay. 270.
It's a big whopping.
So I know in my class, some people have asked me, hey, I don't multiply good. Use what works for you. Use what works for you. All right, this time we're going to use partial products. And you have this problem on your paper. We have 28. No, that one's already done. We're going to do 73 times 14.
Yay. 70 what?
73 times 14.
Oh, no. I was like, wait.
So the same thing here, 73 times 14. We're going to break it into pieces. And again, all you have to know to multiply, no matter how big the number is 1-digit multiplication. If you know your 1s through your 9s, the rest of your life is easy.
Oh, I don't know.
So the first thing we're going to do here, I have 4 times 3, because they're both in the ones place. So I have 4 times 3, which 12. Is what? 12. Now this 7 is in the tens place. So what is 7 tens worth? 70. So now I'm multiplying, I'm going to put this over here. We're multiplying 4 times 70. But again, all I need to know is 4 times 7, which is
4 times 7 is 28.
28. So 4 times 70 is 280.
There's an inch.
4 times 70 is 280.
Oh.
Are y'all comfortable with partial products? All right, so speak up if I mess up, right, Rome? You with me? All right. Now, what place is this 1 in?
The 10th.
10's place.
10.
So I'm going to multiply 10 times, what place value is the 3 in? 1. So it's 3 ones. 10 times 3, which is?
30.
30. And what place value is this 1?
10.
And what place value is the 7?
10.
So I'm going to have 10 times 7, or 10 times 70. And what is 10 times 70? Lily?
700.
700. Yes. Yes.
We're not sure where she belongs.
Yes. Come on in. Come on in. Have a seat. Join us. I don't know. I just emailed them and told them they should come if they want to.
Optional? No.
Only for some. All right. So now the same thing we did. What? Did I do it wrong?
No, I want to work on
Okay.
the board. Then
So the same thing that we did when we added all the numbers in the box together, we do with partial products. But again, if we look, you had to know your 4 times 3. You had to know 4 times 7. You had to know 1 times 3. You had to know 1 times 7. So no matter what this problem looked like, all we had to know is our 1s and our 4s, and we could get this right. Our 1s and our 4s, and we could get this right. So let's call on Hope. Have you added this together yet?
No.
Hope, what's 2 plus 0 plus 0 plus 0?
2.
2. Hope, what's 1 plus 8?
12.
9, 10, 11, 12. Good. 2, carry the 1. Hope, 1 plus 2 plus 7?
10.
10. And again, I don't use this method very often, so I'm not familiar with it. If I messed up, please speak up now or forever hold your peace. Okay, I want you, we already did that one. All right, next, we're going to learn the lattice method. Anybody in here familiar with the lattice method?
No. I've heard of it.
You've done the lattice method?
I didn't
I'm gonna pause you. All right, so this is similar to the box method. The only thing different is we're really only multiplying 1 digit by 1 digit. And what we're doing is I put my first factor there and my second factor on the right-hand side. Each of these is divided in half diagonally, and your paper already has that. Divided in half diagonally. There's going to be a number in each of these triangles. There's going to be a tens place and a ones place in each triangle. Okay? So now, if I do this, just like Battleship or just like we did on the box method, Dax, what's 0 times 1? 0. So I have 0 tens and 0 ones. 0 tens and 0 ones. Okay? Mina, what's 0 times 2?
0.
0. So I have 0 tens and 0 ones. Now we get to the hard part.
Oh no.
Now we get to the hard part. Hope, what is 3 times 1?
3.
3. So I have 0 tens and 3 ones. Okay? And we're going to do it again. And Grace, what is 3 times 2? 6. 0 tens and 6 ones. All I did is I take, and I'm making these like Battleship where they match up. So I have a 3 and I have 1, so 3 times 1 goes in this box. And I have to have a tens and a ones in every one of them. 3 times 2, 3 times 2 would meet here, and that's 6. Now, we're only multiplying 1 digit at a time. 1 digit times 1 digit. But now we have to add. We have to add. So I'm adding this diagonal together. Everything inside the box that's in this diagonal. So that would equal 0, because that's all that's there.
Oh.
Now this diagonal, 0, 0, and 6 equals 6.
No, but if there's a 0, doesn't 0 times 6 with 0?
No, we're not. We're adding them.
Oh.
Here we're adding 0, 3, 0,
3.
3,
And 0.
and then we have nothing there. So if we did this right, my answer should be 360.
360.
And we can check it.
360.
12 times 30. I put a 0 there because that 0's in the ones place. So I can just move it down. And now I'm multiplying 3 times 12. 3 times 2 is 6. And 3 times 1 is 3. Okay? But this one, if you learn this one, again, well, this you're still only multiplying by one digit at a time. This one is still multiplying by only one digit at a time. Okay? And I want you to find whatever method's easiest for you. I just need you to be able to get it right, because as we move into
6th grade.
division, we need to know it. So you're going to use the lattice method. You already have it on your desk, on the paper. I want you to do 22 times 33 using the lattice method. That's a horrible marker. 22 times 33 using the lattice method. And using the lattice method, I want you to solve that. People at home, pause and then do it. And we're back.
Again.
Grace has volunteered to help me here. So Grace, we have a 2 here. Are you watching me?
Mm-hmm.
A 2 here and a 3 here. They would meet here. So it's 2 times 3.
6.
6. So I have a 6 in the ones place, but I'm going to put something in the tens place. There's no tens. My answer is 6, so there's no tens, right? So there's 0 tens. These are tens and ones. Tens and ones. Tens and ones. Tens and ones. So now we get to the more difficult question, Grace. I have 2 times 3, and these two numbers meet here. So Grace, what's 2 times 3?
6.
Oh, good. Here we go. We're getting this now. And we're even into more difficult, Grace. We have 2 times 3, and they may meet here. So what's 2 times 3?
6.
Good. We have 0 tens and 6 ones.
Wow, that's
And Grace,
Huh?
I'm really going to confuse you here. We have 2 times 3 that meet here. What?
6.
Oh, 6. Good. And every one of these has 0 tens, 6 ones. 0 tens, 6 ones. 0 tens, 6 ones. 0 tens, 6 ones. And then it's just a matter of adding each diagonal up. So this diagonal is here, and that adds up to what?
24. What?
This diagonal right here.
6.
6.
Wait, adding all of it together. 6.
Even if you were adding it. Okay, Grace, are you with me?
Yeah.
Probably not.
Who's great? Oh, never mind.
6 plus 0 plus 6 is?
What?
6 plus 0 plus 6 is?
6. 12.
12. Not in here.
12, bro.
So now I have a 2-digit number. Okay, I can't write 12 here, but I'm going to carry it up into my next diagonal.
This is hard.
Okay? 1 plus 0 plus 6 plus 0 is?
7.
7.
7.
So my answer, and then there's 0 here, so my answer would be 726.
20.
And again, I'm not requiring you to use any of these ways. I'm showing you so that I don't have to hear you go, I don't know how to multiply. And then you have to show me, well, show me one of the ways you know how to multiply. And now you've learned 3 different ways, actually 4 different ways, because we've used the standard algorithm. I feel
like every teacher has that. What?
Yeah, probably.
Has what? What are you pointing at?
All right, we're going to start here with this problem. This time we're using the standard algorithm. We've done what some people call the box method. We've done lattice method. We've done partial product. And now we're doing the regular standard algorithm. I still only have to know, if I know my 5s and my 9s, then this problem's not difficult at all. So, Dax, what place is the 5 in? 1's place. So I'm going to break this down, and I'm just multiplying 671 times 5, because that's all I'm doing here. And if I give you guys this problem, You're all like easy peasy raw chicken squeezy.
Yeah. The what?
That's what I said too.
Easy raw chicken
So Dax,
squeezy.
what's 5 times 1? 5. So I have 5 ones. Dax, what's 5 times 7? 35. That means I have 35 tens. Nobody's carrying around 35 tens, so they're making it 3 hundreds and 5 tens. Dax, what's 5 times 6? 30, and then we have 3 more hundreds there, so it would be 33 hundreds. So 33 hundreds is the same as 3,300. That would be the same 3,355. So 671 times 5 equals 3,355. Okay, that's all we did. But if I want to break it into the parts, I want to use expanded notation, then it's easy peasy raw chicken squeezy.
I got that wrong.
Now, do I have it right?
No, I got that wrong. I put 8,845.
Don't say sure, yeah, is it right?
I did 9 times all the rest, but yeah.
Okay.
What?
Well, we're not done. We're not done.
Oh,
All right, I don't want to carry twice. Now, Dax, what place value is the 9 in? The tens place. Good. So I have 671, and I'm still taking the 9, but the 9's in the tens place, and 9 tens equals 90. But again, all I have to do is multiply my 9 times 1, my 9 times 7, my 9 times 6. So now that I'm in the tens place, my first number has to be in the tens place. That's the reason the zero's there. All right, McKenna, 9 times 1 is?
9.
9. McKenna, 9 times 7 is?
35. Or no.
63.
63.
63, good. So that's 63 hundredths. Or 300. Sorry, 3 hundredths. 6
I mean, I'm so smart.
and 3. 3 hundredths, 6 thousandths. Now, Kenna, 9 times 6.
That would be 65 minus 9.
Or Mina,
54.
54.
50.
And then we have this extra 6 up here. So it's 54 plus 6?
60.
60.
Yay, I got the big brains.
So now we're saying 671 times 90 is 60,390. And all we do is we add these two products together. And when we add those products together, the total is
63,745.
63,745. Speak up if we have the wrong
I
answer.
did that wrong. I got 8,845.
Yeah, that is, you did get it wrong.
Like always.
Now speak up if it's wrong, because I didn't do the math. I depended on y'all to do the math. Yes.
3 plus 3 is 6.
Yeah, but you carried one from here. 9 and 5 is 14. So we end up carrying one here, and that's where the 7 came from.
Can I do the next problem on the board?
All right, thank you all for watching the various ways of multiplication. Love y'all. Please subscribe.